For the second part of 10.1, I want to look at the three possible transformations that would happen on the parent function of y equals the square root of x. There are three specific parts that will affect the graph. So here are the possibilities. We can start with our y equals the square root of x, and first thing we can do is we can add a term in front, a coefficient. We'll call that the a term. We can then also add something or subtract something inside the radical. I'll call it the h term. Or we could add or subtract something outside the radical. I'll call it the c term. A and c should be very, very similar to the quadratic section we did in chapter 9. So I want to just lay out what would happen depending on the value of these variables of a, h, and c. First of all, our a, our leading coefficient term in front of our radical, if this value, the absolute value of a, is greater than 1, this will vertically stretch the graph, meaning that the graph, the original parent graph, that might look something like this. If I had a vertical stretch, it would now be going higher. It's like we're taking the graph and stretching it up. Likewise, if that value of a is less than 1, is between 0 and 1, that's vertically compressed. So again, same kind of graph. We'll start with the parent function graph. If that value was less than 1, it's just going to increase at a slower rate. Lastly, if our a term is negative, it'll be reflected across the x-axis. So what this does, so I started out with my parent function. Instead of going up, I'm now multiplying everything by -1, so I'm taking the opposite of every number. It's now going to be going down, reflected across the x-axis. H term. H always deals with the horizontal translation, hence the reason why we called it H. This is going to move it left or right. Tricky thing here is that it actually goes opposite of what you might expect. If H is positive, it actually moves the graph left. And if it's negative, it will move the graph right. So for example, start with my parent function. If this h term was a positive number, let's say h, or our equation was y equals the square root of x plus 2. Again, a positive number, that's actually going to move our graph left. It's going towards negative, so it's actually going to start here at -2 and then go that way. Likewise, if it's a negative number, it'll actually move the graph right, and we'll be starting at a positive number. The last part is C. This is identical to our quadratics. This is the vertical translation area. If our C is positive, it goes up. If our graph is negative, it moves down. And that should be, again, identical to the last section. Next thing I want to look at is how do these three variables of a, h, and c affect the domain and the range of our function. And ultimately what happens is the a and c terms, the terms that are outside the radical, will affect the range, and the terms inside the radical, meaning the h term, affects the domain. So, a, if our value is between 1 and 0 or above 1, it actually doesn't matter at all. The value of a doesn't matter. It won't affect the range or the domain. However, if a is negative, this will flip the range only. As we saw in the last part, this takes it and reflects it over the x-axis, and so instead of having our graph going up and to the right, it will now be going down and to the right. And so our value for our y's is now the values that are less than 0 instead of greater than 0. Our h term, again, remember, only affects the domain. And again, if it's positive, it'll move the domain left, and if it's negative, it moves the domain right. Again, that's flipped how it should be, which means if I have a positive h term, I'm actually making a negative in my domain term. For example, again, if I had y is equal to the square root of x plus 2, my domain is all the x's such that x is now going to be greater than or equal to -2. It moves the graph left. Again, that's opposite of how it probably should look, but that is the case for the inside the radical part. Lastly, with C again, it's outside the radical, so it only affects the range. And just like with quadratics, if C is positive, our range moves up, and if C is negative, our range moves